Good morning, everyone. Uh, am I audible to everyone?
Yes, ma'am.
Yes, ma'am.
Yes. So first of all, thank you everyone for participating in this our second international conference happening on this artificial intelligence and data science. So to begin with this, I request our Chief Technology Officer to declare the session is open.
Hello.
Yes, sir.
Good morning, everyone. It is an honor to stand before you today as we officially inaugurate the International Conference on Advancement in Artificial Intelligence and Data Science, ICCAD 2025, organized by Academy of InnovaWorld and powered by Indian Science, Technology and Engineering Facilities MAP. With great enthusiasms, I now officially declared ICCAD 2025 open. Let us engage, learn, contribute to the advancement of AI and data science for a smarter and more sustainable future. Wish you all the success and the insightful conference. Thank you.
Thank you so much, sir. Now we can officially start the conference. I request Amruta to take over the session.
Yes, ma'am. So, good morning, everyone. I'm Amruta, and it is with great pleasure and enthusiasm that I have welcomed you all participants, guests, and organizing team to this two-day international conference on advancement in artificial intelligence and data science from 29th March and April 30th March. So, organized by Academy Innova World and powered by Indian Science Technologies and Engineering Facilities MAP. So, at the very outset, I extend my warmest welcome to our esteemed dignitary, Ms. Aishwarya Dhara, founder of InnovaWorld Private Limited, whose visionary and leadership has been instrumental in driving innovation and excellence in research and education. And Mr. Pulak Kumar Dhara, a Chief Technology Officer and an organizing chair, and a former assistant scientist at a Department of Atomic Energy, whose expertise and dedication continue to guide our technological advancements. And Dr. Arunava Majumdar, a research advisory, whose invaluable insights and contributions are helping us to navigate over-evolving landscape of AI and data science. Mr. Kishan, a manager of InnovaWorld Private Limited, whose efforts ensure the seamless execution of our initiatives and events. So we are honored to host this prestigious event, bringing together researchers, academicians, industries experts, and students from all across the globe to explore the latest advancements in AI and data science. The rapid evolution of AI and data science is reshaping industries, revolutionizing research, and redefining the way we interact with technology. At ICCAD 2025, we aim to foster insightful discussions, present groundbreaking research, and create a platform for collaboration that drives innovation forward. This conference offers a valuable opportunity for participants to engage in knowledge sharing, gaining insights from distinguished speakers, and contribute to a growing body of research in AI and data science. We are also delighted to offer exciting perks, including e-certificates for all participants, the Best Paper Innovation Award, and opportunity to get published in Scopus Index journals. At the esteemed gathering, I would take immense pride in introducing our conference keynote speaker, Dr. Animesh Roy. Dr. Roy is an assistant professor in Department of Mathematics at SRM University, Chennai, specializing in nonlinear dynamics and chaos synchronization, cryptography, and privacy-preserving machine learning. He holds a PhD in mathematics from Vishwabharati University with research focused on chaos synchronization and cryptography for network security. His extensive expertise includes a tenure as a postdoctoral fellow at Institute of Advanced Study in Science and Technology, where he worked on secure federated learning for medical imaging. a recipient of prestigious awards like Best Oral Presentation Award and the Inspire Scholarship from DST. Dr. Roy has made a significant contributions to this field through his research publications and in renowned journals, including Chaos and Results in Engineering. His technological expertise spans across MATLAB and Python, making him a valuable leader in AI-driven research. We are privileged to have him as a conference chair, guiding us through the remarkable event. With his vast knowledge and expertise, we are confident that ICAAD 2025 will be a platform for impactful discussions, collaborations, and groundbreaking research. So let us extend a warm welcome to Dr. Animesh Roy and look forward to this insightful and enriching conference under his guidance. Requesting Sir to take over the session.
Thank you for the invitation. I'm happy to be here and welcome all the participants and thanks to all the prestigious esteemed valuable members of this conference. Uh, and also I think I am grateful to all of you that I come to for the chair session. And can I start the? Am I audible at first?
Yes, sir. Yes, sir. You're
Yes,
audible,
yes.
sir. Yeah.
So now I start with my talk, and after that the participants will present their presentation, and I am happy to hear again. Thank you.
Yes, sir.
So,
Thank you so much, sir. Yeah. Yes, sir. You can share your screen, sir, now.
yes. Is this visible?
Yes, sir. It's visible, sir. Yeah.
So actually my topic on chaos-based encryption for enhancing security in federated learning for medical imaging, and myself Animesh Roy, assistant professor at Department of Mathematics, SRM University, Kattankula campus. So what is basically federated learning is, at first we have to know knowledge on federated learning. Federated learning is a part of machine learning where they distributed learning where the data can be shared securely and in a large scale. So my presentation overview are, at first, what are the research and questions and importance, and what are the literature till now is developed over this federated learning, and also as in the encryption process based on chaos and nonlinear dynamical system. Next, how we do the research over these two esteemed cases like as chaotic system and cryptographic system and the federated learning or machine learning system, how the methodology will be designed here. Next is hypothesis. Sorry. Next is hypothesis. Which hypothesis we are taking, and the tools that we are taking for this this combining this system and give a more advantage over the medical imaging purpose. Next is the research contributions and what research contribution I have done and the outcomes are there. So first is research question. What is the research questions? How can be a chaos-based encryption enhance the privacy and security of the federated learning? This is my first question. So what is chaos-based encryption? Here I have a model. I hope you guys can see. So this is a total system, a framework of secure federated learning with chaos-based encryption. So this is a medical shops. Let's say this is a medical hospital. This is some data collection center, medical data like insurance. That data are there. These are the patient data ownership. Some ownership companies are there. They have huge number of data. So privacy. So these are the main attacks. Differential types of attacks are go through for the hospital case as well as the client who are involved for these hospital and medical data and the patient data case. So clients may be patient, clients may be some pathological owners, clients may be some other researchers who doing research on medical purposes. So data are flowing all over these. So how the data is flowing? So these these each hospital are training their images, let's say image data at first, training their images with differential privacy. Then they then I introduce here the secure advanced algorithm to do the encryption and update the model and make it into a server. From that server, the clients are downloaded the data in a secure manner with their encryption key. Okay, so for an encryption, what do we need? Encryption has 2 or 3 types, either symmetric encryption or asymmetric encryption or mixed. Symmetric encryption needs private key and the public key, both are, need only one private key, both are symmetric, in which we encrypt and in which we decrypt, both are symmetric. As well as for the asymmetric case, what I have, the public key we have, in which I encrypt, and the private key I share, that I can decrypt. So using these keys, they are based on chaotic system. These keys are developed from the nonlinear dynamical system that is based on the mathematics, a part in which the differential equation make a various role on this. Okay, so using this chaotic system, I made a secure key in which the data will be encrypted. Which data? The trained data. Trained as well as tested data, these data are distributed in the manner of where decentralized distribution system. These are called federated learning. Okay, so the research question is what are the challenges in combined with federated learning as well as the chaos-based encryption in the real-time execution, and also the integration improve and the performance of the scalability of the medical image models, because I am introducing so many things. So people cannot understand. People can download these. They cannot train that data. They cannot develop. They cannot securely get that data. For this case, we have to take the knowledge, the improvement, and the performance and the scalability of the medical image data, because these are the main vital and the emotional issues for the patient as well as the doctors. So now the importance, this is the enhance the security. This which enhance, this ensures the patient data remains confidential with secure encryption techniques, also collaborative learning facilities training across institutions without sharing the raw data. Okay, the scalability, that accommodates large scale diverse data sets while maintaining the efficiency, also the robustness of this security, and the future potential is that if it is applicable, it is applicable in the basis of AI, the healthcare will be more secure in the decentralized methods. Now, state of art, how we will do. So decentralized, what is decentralized data and machine learning? At first I have to learn that first. So these are the institute, let's say these are the different types of hospitals. They have raw data, they are training with some model, and they model as an output, and they are assemble this output. This procedure is called the federated learning environment, consists of n learners or clients or institute or sites. They are jointly trained the machine learning model in a neural network. The goal is to find the parameter W star. It is defined as that minimum of how optimization. Basically, this is an optimization in search of the aggregated loss function of FW, where W is the constant and the D be the model parameter. So loss function here make a crucial role. This loss function we have to define in a such a way that the input output pair is one of the labeled example for the often they referred as a training example. Next, what are the review of literature till now? What I've given in this literature? What is federated in the federated learning model? What are the as well as in the chaos-based encryption model? These are some review of literature. Basically, this the federated learning is developed in between 2015 to 2018. The studied GAN-based inference, the Melis, the famous mathematician as well as a computer science public, as a study the highlight of the privacy attack over the federated learning and introduce the federated learning with differential privacy, in which they established a secure secure distributive learning of the data, in which they can securely send their data, collect their data, and train their data with using the differential privacy purpose. What is the differential privacy? I have to introduce once more. The differential privacy is nothing but I am just giving some arbitrary noise over there. They can accumulate with their data, and the third party cannot train without knowledge of the noise and the without knowing the privacy budget also. Also, these decentralized electronic health record systems are prone to cyber attacks. Okay, these are the risks and the data breaches of an unauthorized access are told by these two scientists, Selim and Park, and they also defined a very very delightful algorithm to prevent these attacks. Next, what I have done in my research and as well as in the further in my postdocs, that secure against the data breaches and using chaos-based encryption technology and spatiotemporal chaotic system I took, and then I used them in federated learning to challenge the computational cost as well as the optimization effect as well as the security purpose. Now, what are the research gap I first find at first? See this. So in 2017, privacy attacks are introduced. 2018, membership inference are introduced. Then the data privacy in 2019. These are the huge accreditation of the data privacy in electronic health record or simply in HR. In 2021, a secure federated learning is introduced by the above said scientists, and also till now they are working on it, that how to how to develop a secure data privacy in electronic health record. In 2022, some scientists and also also introduce chaos-based encryption in this secure to give the more secure and more reliable optimization method using the chaos-based encryption process for the security of the data in medical image and as well as in the raw data also in the different of industry. In 2023, some scientists have introduced semi-synchronous federated learning, and what I have done in 2025, that is not written, that I employed these two chaos-based encryption as semi-synchronous federated learning for more adequately I designed the security in electronic health record systems. So the research gaps I told in year wise, their lack of effective countermeasure of privacy attacks on federated learning. Some limited scalability are there, some insufficient explorations are there, need and more optimization framework. So I introduced the semi-synchronous federated. Already till now the federated learning is developing with mixed also, asynchronous, synchronous and the semi-synchronous. Next, the methodology. How I frame a methodology. This will be useful for the student to research methodology. They have to at first frame, then they have to design. This is the process. At first, what I have done in federated learning as well as in combined with chaos-based encryption, that at first I designed the federated learning and a decentralized medical data aggregates local models with preserving privacy. That privacy is called differential privacy. Next, I introduced a new chaotic system with more secure parameters and as well as more secured algorithm of encryption. Then the privacy preservation comes into the account of medical image and as well as in the data science it will be more useful where image processing or data, different types of data will be accelerated in a large scale that could be combined, that could be useful for privacy preserving, which combines the encryption and the differential privacy techniques to prevent the leakage data during the transmission. Now the research design is that this is the methodology and the research design. Step by step we have to design the how to get the output of a federated learning method. If anyone interested in federated learning method, how they design this, at first they have to initialize it, then they have to do the training process. As they saw the initialization, what I have done it is virtually. One can do with collaborate with the industry, with the healthcare industry and the other industry. They can combine with these initialization like clients, hospital. Then they have to make a key generation hub, key generation server that can be done by there are so many key distributions are there, private key, public key distributions are there. They will initialize the global model. Global model, already trained models are there. You can use that. Also, you can develop a new model and treat it as global model. Then you go for the training progress. Do that first, the local training progress, encrypt the updated, encrypt the weightage updated, then server aggregates the encrypt. This is the homomorphic encryptions that are developing for the server aggregates of the encrypted updates into a global model. Then you can evaluate the accuracy, privacy, and the encryption performance to the existing model, and then scalability analysis in the large scale of data set. If I have a large scale of data set, then iterative improvement. If you have to want to the iterative improvement, you have to optimize the synchronization intervals, encryption parameters, and the able strategies that you have to introduce. So any researchers will focus on these 4 points to design the research on federated learning combined with the chaos-based encryption in any field of domain. Here I introduced on medical images. Now hypothesis. So what are the hypotheses I have taken? I have taken some 2 or 3 hypotheses. The first is federated learning combined with chaos-based encryption. Next is the integrating the chaos-based encryption to enhance security. Third is the federated learning framework improves computational efficiency. For this federated learning, there are 3 types of federated learning in the market basically. First is synchronous, that is all parties are synchronizing with another parties with the central server. Next is the asynchronous, that is central server and the party will synchronize. No other will be introduced in this. Semi-synchronous, where in which I need to synchronization, where I introduce the synchronization, otherwise I don't introduce the synchronization. So main objective is there to validate these hypotheses through experiment, then simulation and rigorous evaluation of the proposed methods. Next is tools and techniques. What are the main tools I need? First is Python. So not only Python, I need TensorFlow, I need PyTorch, as well as the MATLAB, as well as the MATLAB for the chaos simulation. Basically, I did MATLAB for the chaos simulation. The framework is federated learning, TensorFlow, federated already developed in TensorFlow. You can use this or you can introduce a new kind of federated strategy in the coding of Python. Okay, there are so many strategies already there, and you can also do a new kind of strategy that is welcome for that. And also you use the PyShift and also the chaos based encryption. I use the MATLAB as well as you can use on the Python also. No need of MATLAB also there. So the libraries are taken, that is SkillKit run and also the OpenCV for the image processing, Seaborn and the Matplotlib for the visualization in MATLAB. Also hardware, I need this basically. Hardware, whenever you do image processing and image encryption and also doing the image data training for the image classification, image segmentation, and the reinforcement learning and the other things on the images you can do, you need the GPU system, also a cloud-based server for the federated learning simulation, and also for the evaluation matrix, you can have encryption speed, scalability matrix, precision. These metrics you have to develop in your own, as well as some metrics that is like uh, so many NIST provides some development of the evaluation metrics also. So research contribution, I did development a novel framework combined with the federated learning and the secure and the chaos-based encryption to enhance the data privacy and the security in medical imaging. Also proposed a advanced federated learning model that is called semi-synchronous federated learning model for the efficient and the scalable training. Also, I want to design a robust encryption mechanism. Now I am doing over here the robust encryption mechanism to protect against the advanced privacy attacks, as well as also want on differential privacy to reduce the privacy attacks. Also, some optimization algorithms are developed day by day. Also, I am doing and looking for it and improve the scalability of chaos-based encryption for the real-time biomedical application. So there must be, if I do some research, there must be outcomes should be there. The main outcome will be a secure, scalable federated learning model, basically decentralized distributive learning model. This is nothing but this with improved privacy preservation for medical image class. This is my first goal. I asked students to come with me, work with me on this field. I am happy to share my works to all of you. Also enhance encryption protocols. Those who are interested in security and data security in data science program, the encryption protocols must be demonstrated, and also in high resistance. I am looking for also improves accuracy, efficiency, and the robustness of the federated learning model for the device on the medical image task. Also, some contribution on adaptation of security on decentralized system in healthcare application. So these are the references. These are my work on image encryption process and image processing process. These are the some spatiotemporal chaos maps are there. Thank you for your attention, and any questions for any side.
So thank you so much for your valuable presentation, sir. And it's open to audience. Audience, you have any question? I guess we don't have any questions, sir, from the audience. Sir, can we start the session officially, sir?
Yes, yes, obviously.
Okay. Amruta, please take over the session. So, audience and participants, you can start your presentation. The first presenter we have is an Panchua, Arjav Panchua.
Good morning, ma'am.
Yes, yes. You can start your presentation, dear.
Okay. Good morning, everyone. My name is Arjo Pansur, and my topic is financial market forecasting with linear regression. Let me briefly introduce you to the topic first. Stock price prediction is a key area in financial research. Traditional models struggle with market volatility and complex relationships. Machine learning, especially linear regression, offer insight into trend analysis and forecasting. Despite its simplicity, linear regression serves as a benchmark model for the stock prediction. Let me give you a reason as to why this is required. Existing models like ARIMA, neural networks, and deep learning lacks interpretability. Many models do not incorporate alternative data sources such as public opinion. So there is a need for a computationally efficient yet effective model. So I developed the linear regression model for stock price prediction, which will integrate technical and fundamental indicators, compare performance with benchmark models like ARIMA, SVM, etc., and identify key factors affecting stock price movement. So here are the common approaches which are used in stock market prediction. The statistical models like ARIMA, GRC, they are used for time series forecasting. Machine learning models like decision trees, random forest, and SVMs are used for pattern recognition. And deep learning models like LSTM, CNN are used for complex nonlinear dependencies. So they face some challenges, like linear models rely on assumptions of linearity, which affects performance in volatile markets. Deep learning models require large data sets and high computational power. High frequency trading models are sensitive to market microstructure change. So the improvement I will be doing is combining linear regression with future engineering and alternative data sources can improve prediction. So these are some justification. Hybrid models improves accuracy but reduce interpretability. Sentiment analysis can add qualitative insights to trends. Linear regressions with advanced feature selection can be effective.
Excuse me, Arja.
Yes, sir.
Your slide is not moving. You are
Is
working
my
on.
slide not moving?
So
Is it moving now?
yes, they are moving now. So
Okay.
when you are focused on a slide, so please go to that slide. Okay.
Okay, sir. Okay.
Okay.
I was at this slide. Like linear regression with advanced feature selection is effective. So the proposed methodology, it has 5 parts: data collection, data preprocessing, feature engineering, model development, and prediction and interpretation. So in data collection, I have collected data from various sources like NASDAQ, Yahoo, Finance, financial reports, which includes historical stock prices and trading volume earnings. Data preprocessing handles missing values using mean imputation, etc. So feature engineering. In feature engineering, I have computed many technical indicators like moving averages, RSI, Bollinger Bands, and some fundamental indicators like P to E ratio, earnings growth, macroeconomic factors, sentiment data, financial news analysis, etc. In model development, we implement linear regression to model, which will predict stock price movements based on selected features. Optimize model using feature selection and collinearity reduction. So the comparison that my model is better than some else model. So in ARIMA is a time series forecasting model that performs well with stationary stock price data but struggles with non-stationary fluctuation. Random forest is effective in capturing non-linear relationships and handling high-dimensional data sets, but is less interpretable and requires extensive parameters. So the linear regression is simple, interpretable, and computationally efficient. So it is computationally efficient. Matrix is used for model evaluation to compare different models. The study used standard regression evaluation matrix, MSE, RMSE, and R square. So the result is like linear regression performed effectively for trend analysis but struggled with high volatility stocks. Feature engineering played a crucial role in improving predictive accuracy. Hybrid models combining regression with sentiment analysis showed improved accuracy. Deep learning like LSTM excel in complex market conditions but lack interpretability. There is no single best model for stock market forecasting, and integrating multiple techniques provides the most reliable results. So, the conclusion is this study explored stock price forecasting using linear regression and compared its performance against other models. The key findings include linear regression remains a strong baseline model due to its simplicity and computational efficiency. Feature engineering significantly impacts model performance, particularly when integrated technical indicators. The model demonstrated competitive accuracy but had limitations in handling market volatility. So hybrid models combining traditional regression with alternative data sources improve forecasting results. So the future scope for this model is there are potential areas for improvement, which are we can use explainable AI techniques to improve understanding of stock price movements, combining statistical models with machine learning to create more transparent prediction methods, incorporating alternative data such as social media analysis can be used for sentiment analysis to gauge investor behavior. Macroeconomic indicators factoring in interest rates, GDP growth can be used. So the hybrid model, we can use hybrid method modeling approaches like combining linear regression with LSTM for better accuracy and interpretability, using SML learning techniques to leverage the strength of different models. We can use real-time adaptive models, developing models that adjust dynamically to market changes. Thank you.
Thank you, Arja, for your presentation. So, at first, I asked audience have any question.
No, sir.
Okay, but I have a question on. Can you go to slide upper slide? I have seen something. Uh, will it also? So this is a time series forecasting model that refers well. Have you this done or comparative study? This is
I am currently working on it.
currently working on it.
Yes.
So you get the data and you are telling in a position that your model.
I am making a model. I am making a model which will predict the prices.
Yes,
if the stock is going up or stock is going down.
That's okay, but I am asking, you are telling that your model is better than the other. Any comparative study you have done, that is like a table or some existing model that has some graph and your graph is more accurate than the other graph. Have you done anything like this?
No.
So at first, so how can you tell them that your model is more better than others?
It is written that ARIM have struggle with non-stationary fluctuations. Random forest requires extensive parameter, but linear regression is simple.
No, linear regression is simple, but what you have done, so performance metrics, results and findings in here, the linear regression performed efficiency for turn analysis but struggled with high volatility stocks. So these performance would be analyzed either in a table based. Okay, so there should be a table in which the researchers have done and what you have done. Okay, so either a bar plot Do you know the bar,
Yes,
bar
yes.
plot or a histogram plot will be there? Okay, so that
Yes.
these are existing, then this plot is mine and this is the better than this. Okay, so whatever you do like this. So from the existing model, what you have improved, that should
Yes.
be in your presentation.
Okay, okay, sir.
Okay, can you understand my
Yes,
question?
yes.
So improve this in this presentation.
Okay,
That is
sir. Okay.
my advice. So otherwise, your presentation is okay and your paper findings is also okay. Now you are working on it. I hope you will work more on it. Okay.
Okay, sir.
Thank you.
Thank you, sir.
Thank you. Next presentation, Aditya Bharadwaj. Can you please show your presentation and present? Aditya Bharadwaj, are you here?
Yes, sir. Yes, sir. Am I
Okay.
audible?
Yes, yes, you are audible. Please
Yeah.
uh, present
Yeah.
your.
Just a second.
Okay.
Is my presentation visible?
Yes, do it full screen mode.
Yes, sir. Good morning, everyone. So my project is on comparative evaluations of machine learning models, which is used in the businesses, most of the businesses, like mainly in MNCs, to predict the model and also to get the best accuracy required for its company's growth. Okay, so the my project's ability is to analyze the large volumes and data and to extract actionable insights, which has transformed industries and enabling businesses to optimize operations and enhance customer experiences and also improve the financial performances. So in this, I have used some ML models, and uh, I have used this because it's as we all know, it is going to be the future. And today, now the market cap is going to reach by 30.9 billion by 2027, which represents the 28%, 28.7% of the CAGR, and which is a big number in the market industry, in the business industry. And so my primary objective was to evaluate and compare the performance of the different ML models and to get the best accuracy for its company's profits and whatever the requirements the company have the by running these models. Okay, so in this methodology, I have used regression, SVM, random forest, GBM, and neural networks, in which the and also the stacking model, in which we have used to diverse the base models and also by using the meta model in leveraging their strengths and to enhance the overall performances and also uh, to get the best precise decision. So I have run these models, and I came to know that by running these models like decision trees, random forests, and SVM and neural networks, I have came to know that the best accuracy is in the hybrid models such as the AdaBoost and uh, GBM. Here it is. And training time. I know GBM takes more training time, but it gives the best accuracy, which is around 98.5%. And I also took some references from other research papers, which is a slightly 1%, which is slightly 1% less than the accurate model. Uh, the the reference which I took from the research paper was around 99.5%, and mine is giving 98.6%. But yeah, I'm sure that I will be by training these models more, and then I will be able to get more accuracy in the future. Thank you.
Uh, so Aditya, right?
Yes, sir.
So please can you show the graph again?
Just a second.
I believe this graph. Okay. So these are the efficiency and the scalability. So you keep some training time, logistic regression, and number GPM. So at first, when you give a graph, so at first write what is the what make represents the GBM, what mean represent, which graph represents the logistic regression, which graph represents the random forest, which graph represents the GBM at first.
Yes, sir.
Also, the reference. Okay, here anyone cannot understand which is GBM, which is random forest, which is logistic regression. Okay, so I cannot understand from here. So what you do, you make a simple bar like this, that using that bar, you this color make different color. This color represents like logistic, this one random forest, this represents is GPM. Okay, like this
Okay,
you
sir.
have to like, do this. Secondly, in which you are just comparing with, make the reference, make the reference at first. So in the presentation, at the end of the presentation, you give that reference, that this reference I have to, they give that person accuracy, I give that person accuracy, okay, and I am working on it, that is enough. And also go for the title actually.
Okay, sir.
Can you go for the title?
Just a second, sir. S-
Yes. For the comparative evaluation of machine learning models, in which there are so many machine learning models, different fields. Okay. So in which you have to mention at first. Okay.
okay, sir.
Hmm. So title should be more accurate. Okay. Thank you for your nice presentation. Next participant is Aman Malik. Aman Malik. Sorry, Aman Malik. You are here.
Yes, sir. Can you hear me, sir?
So yes, yes. Please show me your presentation. And
Yeah. Sir, can you see my screen?
yes, I can see.
Yeah. Yeah. So, good morning, everyone. Right now, I'm here to present my research paper topic, that is Intelligent Personal Assistant Revolutionizing User Interaction Through Voice Recognition. So, I'll like go to introduction. So, this voice recognition has transformed from rudimentary systems like early speech to text to advanced AI-driven IPS, in which I like to elaborate is that uh, voice recognition began in the 1950s with basic speech recognition models that could understand limited vocabulary. So, over the decades, advancements in computing power and algorithms led to more sophisticated speech to text systems. And by 2010, NLP revolutionized voice recognition, enabling digital assistants like Google Assistant, Siri, and Alexa, etc. And today, AI-driven voice assistants have become context-aware and can operate across multiple domains, offering real-time interactions, personalization, and even emotional intelligence. So, from simple speech processing to AI-powered assistants, voice recognition has transformed how we interact with technology, and the future promises even more seamless and intuitive communication. Now, importance of intelligent personal assistants is that right now, as we see that home automation is largely used in all over the world, like smart lights, smart fans, air conditioning systems, etc. So in that, the AI is this voice assistant is used on largely. And then this customer service, as we see this Amazon or shopping apps or food delivery apps, we see that chatbots that they use for customer service, that is widely used now. And productivities by scheduling is that if there is a Google Meet or anything like that in a corporate world, we see that scheduling is very useful nowadays. But the challenges right now it's facing is noise sensitivity, because some algorithms that is used in these IPAs are not able to catch what is trying to conveyed by the user. And of course the privacy concern, because it is not built on a very well infrastructure. That's why now what my objective is to evaluate user experience with intelligent personal assistant and address gaps that was previously not being focused on. So I'd like to elaborate on that also. That is, while these systems have improved significantly, challenges remain in accuracy, contextual awareness, and user trust. So, to analyze these gaps effectively, a mixed method approach is ideal, like combining quantitative data from user interactions and qualitative insights from interviews or surveys. So, this approach provides a comprehensive evaluation, helping to improve user experience and refine future AI advancements. So, what that and this is my previous research papers I've gone through and analyzed these papers and found some gaps that was not focused on. So that was yeah, so there was limited contextual understanding, privacy, security concerns, and scalability issues. Like there were no API used properly in those. In my paper I used uh, TMDB API, that was for TV shows and all, Dream Studio API to generate visual uh, visual images and videos, then Open Weather API, News API to, if AI is widely used nowadays, so at least the voice assistant has like some features that we can ask and it can give proper answer regarding to that. So for that I'll say uh, yeah, so I will elaborate those is that news API will be used to, like, if I ask uh, the voice assistant that what is happening right now in India, so it will give me some few uh, headlines or what is happening today, what is going on in southern parts or in northern parts, etc. Then if I tell you to generate me a picture of an animal having glasses, then it will generate something kind of animal wearing glasses. For that I use Dream Studio API. So yeah, for I'm proposing is this already elaborated qualitative and quantitative. Then the features is that real time info, I said, weather, news, then entertainment. For I've used this TMDB API, which gives this TV shows information. Then privacy focus, no, because in this model there will be more privacy focus, in which I am working on to in future I want to allow combine this security feature with using blockchain technology. For So it will be more beneficial and will be more efficient from this previous voice assistants that has been published. This is the right now comparative study of those previously discussed IPS, and this right now what I am working on. So there is be more customizability, how I want to use it in my home appliances or in corporate companies. Then privacy, that I said earlier, just right now, that I want to use blockchain technology to combine with this, so there will be no data sharing and there will be more secure, and it will be cost will be free. Like it is just a model right now, so it will be on the earlier stage, it will be free. Then we can work on like a subscription model, and we can think about it later. What limitation these papers previously ever had was noise sensitivity, of course, because the model and algorithm that were used was not very efficient to understand what was saying, like it was not able to capture those exact words. Then API dependency, there were no proper API used, and that's why they were they had a very big challenge. Like there were no Dream Studio and Open Weather because that time AI was not that much efficient that is right now. Then yeah, so key findings in this is that streamlined tasks but need contextual awareness, privacy and accuracy are critical for trust, and propose item access and customization and cost. My future ways is to enhance noise cancellation to get the proper outcomes of what user trying to convey. Then expand language support. Like I want to use multiple language support like Hindi, Gujarati, and all over like multiple languages I want to use in this, and integrate blockchain for security as I just said, because the model needs to be secure and there will be no threat or yeah. So that's what I want to do regarding my model. Thank you. Uh,
Thank you, Aman, for your nice presentation.
yeah,
And any audience has any questions, please?
I'll be happy to answer your questions, audience.
So my question on actually I am working on privacy. So can you what privacy preserving you are just taking for the voice recognition?
So right, what I'm using in privacy. That's what are you asking?
Yes.
So sir, there is this model that I found. Which has this few APIs that were used. But for that, I'm using different algorithms that is like,
Can you show the bigger model? Actually, not that model, the diagram or something like that.
yeah, I can show you. Can you show you my paper that
No, no, it's okay. So when you do work on some model, so I
yeah,
know it is a private model. So
yeah,
what you do, you give some basic outline of diagram that this work on there. So if who seen your paper,
yeah,
whoever is seeing your paper,
yes,
he or she can understand that
yeah,
yes, this is what you are doing. No,
yes, sir.
only writing is boring for people to
Oh,
gain the knowledge. Okay.
yes,
So can you go to the slide where you are taking the privacy setup, right? Blockchain technology, I hope.
sir. In the future, I have said that I will be integrated blockchain for security, but
Blockchain for the security. Actually,
yes,
blockchain for the security, that is working in nowadays. The people are working, but it is a huge algorithm and
yes, sir,
huge cost for the security. Actually,
yes,
right?
sir.
So
But
can you do it in different way? I hope.
yes, sir. But the thing is, in my college, there is one department which can help you. Like they will fund you if your idea is great. So I can propose this model to them, and if it works out, it can be useful.
Hmm. So please work on that. That blockchain model is actually for the Bitcoin
Yeah.
that they are using it.
Yes.
So
Yes.
they have no issue with this. But whenever you face recognition and these kind of things, the blockchain security, it's okay. It's okay, but it is the cost of the privacy. The
Yes, sir.
budget of the privacy is very high actually.
Yes, sir. That's why I
So,
said ki after initial level, it will be subscription plan for
mm,
whoever you want to purchase. So yeah.
okay, thank you for your nice presentation. I hope
Yeah. Thank you, sir.
next is Ania
Yes, sir.
Rodriguez. Okay.
Yes, am I audible?
Yes, you are audible. Please share your screen.
Yeah. So is my screen visible?
Yes, visible. Visible.
Good morning, sir. Myself, Anya Rodriguez, and my topic for research is comparing the traditional machine learning and deep learning models for predicting the price of pre-owned cars. These are the overview of my presentation. We'll go through introduction, followed by literature review, proposed methodology, comparative study, and lastly conclusion. In today's life, cars are a necessity that cannot be skipped. But with the rising rates of inflation, not everyone has the capacity to own a car. Thus comes the idea of buying second-hand cars. These cars, which have been pre-owned previously, are a far cheaper option than buying a brand new four-wheeler. The pricing is done mainly based on factors such as years of usage, kilometers driven, the mileage, max power, seats, and many more. This provides a problem for both the sellers and the buyers. Sellers may get exploited by the car dealership owners by not receiving the proper amount due to lack of knowledge, while buyers, on the other hand, may be faced with overpriced deals. Predicting the accurate car price is very important for effective decision making in both the buying and selling process. To resolve this issue, I have implemented machine learning and deep learning models to predict the price. Let's discuss some of the existing research in this domain. There are several studies which have attempted price prediction using different models. For instance, K nearest neighbor was found to be 85% accurate, but while comparing it with other models, it showed limited impact. One more study by Enis Gegic, he proposed using ensemble model for predicting the price because during his research, when he applied a single model, he got accuracy of less than 50%. So he approached this model of ensembling three models and he got a good accuracy of 87%. Next, in one of the study, lasso regression outperformed the linear regression model, proving that feature selection plays a vital role while predicting the price. However, many of these studies were conducted on small datasets, leading to potential bias in results. Random forest and gradient boosting were found to be reliable models in most of the studies for regression tasks. While past research provided valuable insights, there are still some gaps that needs to be addressed. First is comparison of multiple models is missing in many of the studies. Secondly, understanding which feature impacts the price most is crucial for better prediction. And lastly, the dataset limitation. Most of these studies have used small datasets with keenly 97 records, which limits the real world applicability. Um, Moving on to methodology, the flowchart in the right is my proposed methodology. First comes the data collection, followed by pre-processing, then training all the models and comparing their error rate and accuracy and finding the best model for prediction. The first step is data collection. The dataset used is taken from Kaggle containing 15,000 records with features like the present fuel type. Here's the data description of the dataset I have used. Next, the data underwent pre-processing, including handling the missing values, encoding categorical features like the transmission type, seller type, and lastly normalizing the numerical values. Also, I did remove some of the rows like outlier removal because the high price, because of the luxury cars, the price was very high, so my model skewed. So I did remove some of the high priced cars. I implemented four models from basic to advanced. First, the baseline model linear regression, which then comes the random forest, gradient boosting, and for deep learning, I implemented ENN. Performance was measured using three key metrics, R2 score, the RMSE, and the MAPE. RMSE and MAPE is used to find the error. After training and evaluating each model, I performed a comparative analysis with capturing the nonlinear relationships like car depreciation, leading to low accuracy. Higher MAPE score indicated greater deviation from actual prices, which in most cases was for luxury cars. Secondly, random forest performed better in handling the nonlinear relationships more effectively than the linear regression model. Gradient boosting outperformed all the models, achieving the highest R2 score of 0.93 and the lowest error rate, that is the MAPE score of 13.5%, making it the most precise model among the four. The NN model shows a lower RMSE score, indicating it to be much better than the linear model. It has features to capture the complex patterns, which can be improved using hyperparameter tuning. In conclusion, my study compared different multiple models to predict the price. The comparative study confirmed that gradient boosting performs best, achieving the highest accuracy and the lowest error. Future research can explore you implementing the models on diverse data sets and then doing a comparative analysis and finding which model is the best for predicting. We can also incorporate accident and maintenance history for better price estimation. Collaboration with insurers and the service centers to include the accident severity and service records could also make a price prediction more accurate. By increasing vehicle history data and growing our data sets, we can get even more accurate and subtle price prediction. Thank you.
Thank you for your nice presentation, Ania. From audience, any question? So from my side, please, can you show the methodology once more?
Yeah. The flowchart.
Yes, this project. Okay. So here you are, yeah, this will be compared with deep learning and ML models. So compare deep learning means compare existing models or compare you are just with, in which do you compare with?
Like, sir, I'm comparing the machine learning with deep learning. Like, is deep learning better? Because recent studies, they have only used 1 2 machine learning models and they've predicted the price. So I thought traditional machine learning and ANN, comparing both of them, which could be better. Actually, ANN can perform well if we use hyperparameter tuning. I haven't really applied that yet. So I'm just
So
comparing. So according to my research, right now traditional ML
no,
model
you
is,
are. I am asking that in which you are comparing with the existing models that is in market or the papers, research papers. They are making some models with them.
no, existing models, sir.
Existing models,
Yeah.
existing ML models with. There are so many deep learning models also there.
Yeah,
You are
I'm using basic ANN.
basic ANN.
Yeah.
Okay, so you are using basic ANN and comparing with existing deep learning as well as machine learning model, right?
Yeah. Yeah.
Okay, so whenever you call that comparison, okay, so there should be a slide in which you have compared. Okay, so these are the models I have compared. So there is a bar chart will be there that my model is giving from this model. This model is accuracy is this. Do you make this table? I hope any
I
table.
made a accuracy table. Yeah.
Yes, you did the accuracy level. Yes. So this is the comparison table. So you make a bar chart like this. So you don't mention which model you are taking to compare with. Okay, the
Okay.
linear regression and numbers model.
Yeah.
So these are the there are so many linear regression models. So
Yeah.
many authors are in market. So many random forest models. So many ANN models, and in which you are taking. So this is little bit healthy. So in whenever you do, please mention this model. That is, like say, if you are taking some existing model, machine learning model, so many machine learning models are there. I don't remember existing machine learning model. And existing another random forest models are there. So you will just compare with mention that this author has introduced this model, I have introduced this, and it makes a flowchart.
Yeah.
So overall, thank you. Make sure whenever you make a comparison table, be more specified. Okay.
Yes, sir.
Thank you. Thank you, Ania. So next participant, Aryan Sivastava. Aryan Sivastava, are you here?
Yes, sir.
Please share your presentation.
Good morning, everyone. My name is Arun Srivastava, and I am honored to present today on my research topic Advancement of Computer Vision in Autonomous Vehicles. The research explores the role of computer vision in self driving technology and the challenges it faces. Autonomous vehicles present one of the most revolutionary innovations in modern transportation. They rely heavily on artificial intelligence and more specifically computer vision to interpret the surroundings. The objective of the presentation is to provide an overview how the things have been in the past few years. Computer vision provided enhanced object recognition and more precise real-time decision support with continuous learning, making the cars and the vehicles more responsive to the uh, environment it's present in each and every country or even the cities that they are in for their driving conditions and the driving habits of this place. The object of the research was to find what computer vision is playing part in the field as well as what it is what are the challenges it is facing and what are now the technologies that will help in providing more sophisticated resources for computer vision to be better in the autonomous vehicle field. While in the past, every from 1980s to every 10 to 20 years, there have been evolution where in the start only the robotics companies were interested in this topic. Now, after 1990s, companies like Bose and Nissan were the first to actually give proper AI and computer vision based solutions for the uh, due to the emergence of AlexNet being the first proper computer vision based AI, and now through YOLO and higher multi-box selection AI and recognition classifiers can be more powerful and efficient. Computer vision at its foundation is built enables the vehicles to recognize the objects, detect pedestrians, and interpret the traffic signals. Over years, advancement of deep learning and neural networks have significantly improved the accuracy, making the historical milestones like having the knowledge of what is in front of you, what is there, and now with the proper signage on every road with lines can allow ADAS, which can be incorporated in cars without having proper AI, just basis on algorithms. But now with AI, it's totally different. The trends like Tesla's cameras and lidar sensors throughout the vehicle changes what happens to the vehicle and also for their disaster prevention mechanisms. With the previous sensors and the advancement like the cameras, the dash cams, the motion sensors, the IR sensors, the lidar sensors, now integrated with deep learning impacts it very much, giving more accurate but also having forensic report of what could have been done better in the situation, basically making AI not a black box anymore. And the core concepts which I am going to discuss is about what kind of segmentation computer vision does, with what features the sensors provide, and what real-time object detection algorithms there are. Computer vision primarily functions through image processing with the usage of cameras and lidars, which provide a very comprehensive view of what exact position, location, and the measurement of the object right in front of it. while features like this could actually help the vehicle to maneuver through difficulties. The newer CNN models like YOLO and will be suffice for providing future perspective to this, but we need more sensors that could be help in digital forensics for finding what disasters that could have happened or could have been prevented if the AI model could have gone wrong. Mostly deep learning models like CNN, RCNN is very effective and provides exact geolocation and stuff could help so much more. But in real time, the efficiency like these are already checked by in Formula One for conducting races and stuff. But the reaction time and the decision making does not help even if power is there. So we need more technology to enhance the result of AI in this speed while making sure it's safe on the road, because the Formula One AI championship has so many qualification layer, but mostly all of the solutions that were provided ended in a disaster, breaking the vehicles and causing very much expense and as well as economical loss. While the sensors like LiDAR camera infusions mostly provide the most robust and more precise, we need real-time data processing so much faster, like a supercomputer or something around there to be there. The challenges it faces is that the lighting conditions, the way the cleaning of the vehicle, the camera lenses, their accuracy, with now up to a basic modular camera lens up to like 140 megapixel, something can provide so much more than what Tesla is providing right now. Tesla's every single camera lens is now about 24 megapixel with a very high focal length and up to a very low focal length at the same time, providing it, giving it more information, but not being able to provide exactly like it would perform very bad in India as a country, as a suburban country like India, Pakistan, Afghanistan. They wouldn't perform anywhere close because we have like an indigenous traffic which doesn't follows the rule at the same time is much more safer if a mistake happens in our country. We survive even in the worst driving scenarios, while these guys, one mistake will cause an accident, though they have prevention for that. The latest technological advancement like YOLO, FASA, CNN, or any other one will provide a more secure yet faster, the tremendously faster. Like in 1980s, they had AlexNet, which could identify only one. Now we can identify many, including crowd, cars, classification, vehicles, animals. Each and every one of them can be easily, and also the car can maneuver, the vehicle can maneuver. Now after Tesla, Uber, Ola are now creating autonomous vehicles, trying to create their own AI for autonomous vehicles. Not in India specifically, but other companies like the drone company Digin also is trying to create a proper AI for drone running through fields and stuff, providing target and objective detection. AI driven detection and real time data production requires proper opening phases, like how much far it can look, what is the distance between having that, plus what happens if at that distance we get hit by something. It decides on every single it decides which lane it should put in, what's the fastest lane there is, while all of this are supposed to be made in like a 0.23 millisecond of decision period, which is like more than a cricket batsman on the field. Yeah, and that's how quick it is. Most of the case studies have the innovation through sensors and lidars, but not computer vision itself. We need more around those techniques right now, with applications with integration of technology and implementing on traffic management through the government itself. We can now implement like the proper controls we need on the road, to create more safety measures for exactly these vehicles which are not handled by humans, because they can be vulnerable to misjudgment or prejudice under a few situations, which can now lead to improvement. We will now be talking about edge computing around the.
Aryan, can you hear me?
Yeah, yeah,
So within 1 or 2 minutes, please.
yeah. It's just over. So, hmm. So let's see the end of it. So I will be talking about the regulatory policies that should be implemented, keeping a safe distance through these vehicles, giving it accurate space, and how you should, as a person, maneuver through these vehicles like an emergency vehicle. So for the conclusion, technology integration with the real world application will face more future challenges because newer sensors will be adapted and require more application and solutions through those. For us, the older approach and the Tesla's newer approach is the best to go by as a base, while we should actually do more research and do more ethical framework development and more disciplined research like physics, laser development, and more stronger. So I would like to conclude and thank you for listening to me.
Thank you, Aryan. So any questions from audience? Audience?
सही बड़ा लिखा था यार
diagnosis is the time consumption. So it requires expert analysis, which can delay treatment. Subjective difference, radiologist may interpret the same image differently, prone to errors due to fatigue or various inexperience. Misdiagnose can occur with the advancement in the artificial intelligence and deep learning model shown remarkable success in automating medical imaging analysis. The model can analyze thousands of X-rays.
Your slides are not removed here, not.
Sir, because it's still here, I'm explaining here because the next slide is a literature review, sir. That's why. X-ray imaging in the second. Where am I? Uh, where was I? Okay.
Please proceed.
Yes, sir. I just forgot where am I. uh, Medical imaging, however, limitations such as okay. So the main limited we can say is the limitations of the X-rays that are there are many diseases that are uh, unrepresented unrepresented, like that are not detected, that that specific type that it should like COVID or something else. So the main thing is limitation, explainability, and computational complexity, because the CNN needs computational power to train the model. That's why the limitation. The research objectives. In the research, they compare the performance of multiple deep learning models to determine
Your
which.
slides are not
Sir,
moving.
I just moved slide because the literature I came to literature review. Because of the net. Right now the net is used. That's why maybe. I'm on the third slide. Hello, sir.
But it is not visible actually. So you can proceed. No issue.
Okay, sir. So the literature review deep learning models, comparing the performance of multiple deep learning models to determine which architecture is the most effective for the lung disease. Evaluate the impact of assemble learning techniques, which combine multiple models to improve accuracy. Then the investigate the challenge related to the model interpretability and computational efficiency and explore potential solution. So we are here in the research gaps. So despite CNN-based classification of the lung disease, there are many shortfalls. So the main shortfall is a model interpretability. Deep learning models often function as a black box, so we don't know, sir, exactly how the decision-making process is done. The data limitation, the medical data set are often imbalanced, with some disease being unrepresented that I said before. Then the computer cost, the training deep models require significant computational resources. That's the main thing. Then we are going from the methodology, and then the data collection. I used, sir, the data set is just X-ray 14 that are contains uh, 1000 1120 labeled chest X-rays images with the 14 different lung diseases on the large data set for the medical image analysis. Then there is the COVID-19, another data set that I take from the Kaggle. Introduce the X-ray images of COVID-19 and the normal cases, useful for evaluating deep learning models in pandemic related applications. Then the next step is the image realization, and the standard all images are 224 x by 224 pixels to maintain consistency. Then we do normalization. Scale pixel is between 0 to 1 for faster and more stable training. Then the data argumentation and the class basis. Since the database were in balance, some diseases had fewer samples and some are oversampling. So we weighted loss function to ensure fair training. Then the deep model section, model selecting sections. So we use VGG16, one of the first CNN architecture, and deep learning, but prone to overfitting due to its large number of parameters. Then we use ResNet 50, introduce skip connection to solve the vanishing gradient problem. Then we use DenseNet one-to-one, use dense connection between layers, promoting better features. Then we use hybrid CNN plus LSTM, combining CSN and LSTM, useful for analyzing disease progression over time. Then the evaluating metrics we use for the model, we evaluate metrics. We use accuracy, sensitivity, that are measure how well the model detect the disease cases, and the specificity that uh, will measure the non-disease cases to correct classify. Then we use AUC ROC, assemble how well the model distributes between positive and negative cases. Then we use F1 score to balance precision and recall, especially useful for like this imbalanced data sets. Then the performance so the summary is VGC16 perform like 86%, while with overfitting achieving an accuracy of 86%. Then ResNet showing improvement in 92% accuracy, benefiting from the residual learning. Then the DenseNet one-to-one performed the best among individual models with the accuracy of 91.2 and AUC ROC of 0.95. So the conclusion and the future conclusion and future direction is in the conclusion. Research confirms that deep learning is powerful tool for automated deep detection, and for the which model that are good for the detection is the DenseNet one-to-one is the best standalone model due to efficient feature reduce. And then is the assemble learning. ResNet plus DesNet achieve the highest accuracy, but requires more computation. So it if because it requires more computational, it takes uh, more resources. That's why it is not preferable right now. Then that is hybrid model. CNN plus I use CNN plus LSTM. May be useful for advanced cases such as tracking disease progression over time. So the future direction, research direction is to improve training on large, more diverse data set to improve generalizability. Then develop a real-time detection tool for clinic use. It's so the right now there are no tools and models that are used in clinics. The model are used in big hospitals, and that's it. Then the enhanced model interpretability techniques like CAM to visualize how model make decision. And the closing. So the summarize, the research demonstrate the efficiency of the deep learning in the lung disease classification, while the deep learning models like DenseNet, ResNet significantly improve accuracy. There are challenges in terms of interpretability and computational cost. As we forward, yes sir,
Sam.
yes sir.
So actually what happens, so public don't see your slides at first. So I am stopping, early stopping because already 11 minutes over for you. So
Sir,
what
it's the
happens?
conclusion. Sir, it's a conclusion. So may I
So
conclude, sir?
Okay, its conclusion is okay for you because people are not seeing your slides. So next time, whenever you prepare, please consider the net connection. So many
I don't know,
questions.
sir. So
For,
I checked the internet speed and it's okay. I don't know
so I
why
did not
it's not.
see any slide.
So
Okay.
maybe I present one more time.
No, it should not be possible because it's a one-time presentation, right? So whatever, it's okay. Uh, your work is good, and I think because I am working on it, so BGG 19 is also there in the
Yes, sir.
in the market.
Yes. So
Also,
VJ 19 I try, but it's a little bit
so
complicated.
many
So
parameters are there. Okay.
yes, sir.
Also, RES net
Resident, sir.
one two
Yes.
yes
One
one
to
two
one.
three
One to
one
yes, 1 2 3 is also available, sir.
also there, that is also gives the more efficiency. Also, it actually what happens in deep learning, these kinds of models build huge kind of numbers of models, so their overfitting is like a simple case for these cases. Okay,
Yes, sir.
so that's
Okay.
why I will ask you to make a improved model. Don't use the existing model VG16 or VG19 like this. So
Okay, sir.
use in case your model and use the ImageNet as
Yes, sir.
for the training of the data and apply on it. So
Okay,
I
sir.
hope you could make your own model. Okay, so that is
Okay,
my
sir.
suggestion. Okay,
Yes, sir.
so otherwise whenever you are presenting in this kind of platform, so please ensure that your net connection will be okay, your
Sir,
platform should be
sir, I, I,
responsive.
I checked for 3 times and it's showing good connection. Like my plan is 30 Mbps and it's showing
So
25 and
it's
26.
it's
So that's why.
it's it's
I
okay.
don't know, sir.
Thank
I'm
you
very
for
sorry. I'm very sorry
your
for.
thank you for your presentation. I any questions from any side? So I asked Chinmoy, are you here?
Yes,
Sam,
sir.
please stop sharing.
Yes, sir. Sorry.
And Chinmoy, are you here?
Yes, sir. Yes, sir.
So
Am I
please
audible?
present. Yes, yes, you are audible. Please share your PPT.
Yes, sir. Good morning, everyone. I am Chinmay Khanzode, and today I will be presenting a research topic on speech emotion recognition, a crucial step towards improving human-computer interaction by enabling machines and recognize, interpret emotions from speech. Uh, Going to the introduction, emotions play a vital role in our communication, influencing not only what we talk, but how we say it. Emotion recognition utilizes artificial intelligence to analyze vocal expressions and identify emotions. This technology has promising applications in the sector of healthcare, customer service, and human computer interaction, helping systems adapt to user emotions and provide better responses. The objective of my research, first of all, let me show you the workflow of the speech emotion recognition. These are the parts of the speech emotion recognition, in which pre-processing, feature extraction, prediction and classification,
Excuse me,
model
Chinmoy.
evaluation, model. Yes, sir.
Your slide is also not removing. Any problem with that? Yes.
Let me check,
Now I
sir.
can see.
Okay, you can
So,
see.
so participants are
Let's
requested. So please remove the move your
Can you
slides.
see it now?
Yes, I can see. Do it full screen. Yes.
Yes.
Now it
Now?
is okay. Now it is okay.
Okay.
Please proceed.
I'll move to the objective. My research aims to evaluate and compare the performance of five machine learning models, which are support vector machine, random forest, decision tree, k nearest neighbor, and naive Bayes model. I've used a data set which has 1440 audio recordings and actors portraying 8 emotions: neutral, calm, happy, sad, angry, fearful, surprised, and disgust. The proposed methodology to achieve reliable results, we followed a structured approach. As I said about the database, I have used the RAVDAS dataset, which consists of professionally recorded, approx 24 professional artists have recorded these speech samples. In pre-processing techniques, noise reduction I have used to remove unwanted background noises, pitch shifting to introduce variation for better generalization of the data samples, trimming and padding to standardize the audio length for feature extraction. Now the extracted features from the audio samples are MFCC, which is male frequency septal coefficients. This helps to capture human auditory perceptions, captures short-term spectral information used for primary feature in SER task. This is the most important feature which among the four given. The second feature is the RMS energy. It is used to measure the sound intensity, reflects high energy segments for emotion detection. The third is zero crossing rate, that is ZCR, measures the rate at which signal changes polarity, useful in detecting speech patterns. It is used for speech patterns. Chroma features to analyze the pitch and harmonics. These are the four extracted features. The next is model training and evaluation. As I said, the models I have used for this is SVM, random forest decision tree, KNN, and knife based. The model evaluation, in model evaluation, I have used accuracy as a measure, precision recall, and F1 score for the model effectiveness, confusion matrix to analyze the classification. Also, I have used the cross validation to ensure the reliability across the different data sets. This is the pipeline overview where the input voice, which is from the RAVDES data set, which does first noise reduction and pitch shifting. Then the four features are extracted, which are then put into the machine learning models, and the final predictions are made. These are the results which I got from the my models which I have trained on the data set. The SVM delivered a strong performance benefiting from well-defined decision boundaries. Random forest managed multi-class classification but prone to overfitting. Forest was prone to overfitting. KNN was highly dependent on the distance metrics and value of K. Nav base was performed purely due to its assumption of feature independence. We encountered several challenges such as high feature dimensionality affecting computations and noise variations impacting real world performance. As I have described the poor results of the assumptions of naive base, these are the challenges identified: high feature dimensionality impacting computation, overfitting of the tree models due to dataset size, and the real world problems which are noise variation even after removing the noise in the pre-processing. The conclusion of my research is that SVM and KNN models performed the best when combined with appropriate feature selection. The data augmentation techniques like pitch shifting further improved model robustness. While naive Bayes is computationally efficient, it struggles with a complex multi-class classification in speech emotion recognition tasks. My final thoughts are speech emotion recognition is a rapidly evolving field with huge potential in AI driven applications. The future work should focus on deep learning approaches and real world noise handling techniques to enhance the accuracy and robustness. Thank you, and I'll be happy to take any questions.
Yeah, thank you. Chinmay,
Okay, sir.
for your nice presentation and on time. So yeah,
Yes,
I
sir.
asked everyone if any questions will be there. So can you show me the methodology actually? Which method you have
Me-
followed? Yes, proposing.
in
Methodology.
methodology first, yeah.
Next slide. Yes, it's
Next, this
proposing.
one.
Yes, model training, support vector machine, random forest, decision tree, can this is so okay, you are using these five or
Yes.
one of these
No,
five.
I have no, I have done a comparative evaluation
So where is
between
the
these.
comparison basically?
Sorry, sir.
Where is the comparison? Graph or
Comparison.
yes,
So this is the comparison.
yes, this is the comparison for the yes,
Comparison.
yes.
In which SVM was the best performing and the knife base was the least best performing.
So in the it is your speech recognition, right?
Yes, yes.
So for this case, also some existing models are there already.
Yes.
So they are
Yes.
using. Can you compare with their models also?
So
Actually,
they are not using this data set which I have used, Ravdel's
no, no,
data
no,
set.
no, no. That is not the issue. Okay. So issue is that model is model. Your data set, there are
Yes.
so many different data sets will be there. So
Yes.
what you have to do, so please compare with existing. These SVM, random forest, NV. So
Okay.
they are using these methods. So many methods are
Okay.
there. So these are the
Yes.
well-known methods already developed
Hmm.
in the market. So
Yes. Yes.
also new methods are coming. So
Yes.
compared to these, your platform, your methods is how much is good. Okay, your
Okay.
innovation, how much improved from the existing method. That should be known to us. Okay, so
Okay.
okay. Also, your presentation is nice, and also your work is also nice. So you are in the basic stage, I hope. So you
Yes.
improve
Yes.
in that way. I think
Okay, sir.
this suggestion will be helpful. Okay,
Okay.
thank you again. And
Thank
next is Daksh Sharma.
Yes, sir.
Yes,
Am I
you are
audible?
here. So please proceed with your
Yes, sir.
presentation.
So, can you see my screen?
Yes.
Yes, sir. So, good morning, everyone. Today, I'm here to present my research topic on emotions on Reddit discussions. That is, unveiling emotions on Reddit, a deep dive into social media sentiment. So, social media has become an important space for people to express their thoughts and feelings. But how do emotions differ across online communities? So, that's what we aim to cover in this study. So, with the rise of online platforms, emotional expression has changed, especially on Reddit, where anonymity gives users a sense of freedom. So, this study focuses on analyzing emotions in Reddit discussions to understand what emotions dominate and how they vary across communities and how we can detect them. So why Reddit? Reddit is it is one of the most diverse and active discussion platforms with thousands of subreddits covering topics from mental health to politics. So, uh, what makes Reddit special? First is anonymity. Second is longer discussions. Unlike Twitter's short post, Reddit allows detailed conversations, and different communities discuss different emotions. So, research objectives. In our study, we focused on three key goals. That is, first, identify the most common emotions and analyze how emotions differ across various topics, and then evaluate techniques to detect emotions accurately. So we ask questions like what are the dominant emotions in Reddit conversations, and do emotional tones change based on subreddit type, and how we can improve emotion detection in social media analysis. For scope and limitations, the scope, while our study provides valuable insights, there are a few limitations. For example, the first, context misinterpretation. Just as the NLP models and AI may struggle with sarcasmic subreddits and data bias. As we already know that all of the people in the world do not use Reddit, so we cannot represent the general population. And the third one is text only focus. The techniques we used did not focus on images and memes. So despite these challenges, our study provides a strong foundation for understanding emotions in online spaces. This is the literature review. Previous research highlights key differences in emotional expression across platforms. So, Twitter uses short posts, and Facebook posts tend to be more personal and curated. And when this Facebook posts come to life, they are in a positive tone because people share the personal beliefs there, and they are not anonymous. Whereas Reddit, the discussions are deeper with more openness. That brings a balance of positive and negative both the emotions. This study shows that anonymous platforms encourage stronger emotional expression. So Reddit is a unique place to analyze. The theoretical framework, the Plutchik's wheel of emotions, it shows the 8 primary emotions, which are listed here. Then the Ekman's 6 basic emotions: joy, sadness, anger, fear, disgust, and surprise. So it focuses on core emotions, and effective computing uses AI to detect emotions in text. These theories help structure our analysis. So the gaps are a lack of research because there are not too many research that focuses on Reddit as compared to the other platforms like Twitter and Facebook, and the data sets available are very limited. At the same time, the existing methods focus on positive and negative both the sentiments, but very few classify complex emotions like anxiety and excitement. The proposed methodology, research approach. To analyze emotions on Reddit, we used a combination. The first is lexicon based, that uses predefined emotions. The deep learning models like Burn and LSTM, they detect emotion based on context. This helps us achieve better accuracy in sentiment classification. The data collection process. We have collected Reddit comments using the Reddit API and selected subreddits based on emotional diversity. For example, the r/depression that indicates high levels of sadness and empathy, whereas the news, it indicates strong expressions of anger and frustration. At the same time, the relationships one, uh, a mix of joy, sadness, and anticipation. To prepare the data, we removed irrelevant words, standardized text, and labeled emotions for the further analysis. So the techniques were we tested the different emotions analysis. The Vader, it is effective for social media sentiment, and the BERT, it is a deep learning model for complex language understanding. We also used word clouds and emotion trend graphs to visualize the sentiments. The comparative analysis between Reddit and other platforms is given here. Our findings relieved key differences between Reddit, Twitter, and Facebook. So, Reddit is longer, deeper discussions and leading to a stronger emotional expression. Whereas Twitter, it is more immediate and it is reactive and driven by the current news trends. At the other hand, Facebook is more personal and often positive due to real identity usage. This comparison highlights Reddit's unique role in online emotional discourse. The key findings. Key findings were the emotional. First, the emotional trends vary across subreddits. Some communities foster support while others drive debate. The negative emotions, such as anger, frustration, are more common in political or the other subreddits, while positive emotions appear in more casual subreddits. These findings help us understand how different online communities express emotions differently. So, the implications of the differences. Why does this matter? First, mental health analysis. AI can detect distress signals in online communities. Second, social media trends. Understanding how emotions spread helps in content moderation. And the third is business and AI development. Companies can improve sentiment analysis tools for better customer insights. So, this research has real world application in psychology and technology. The summary of the key findings. Reddit's anonymity leads to more open and emotional expression. AI models can help analyze emotions but need improvements. So we need to fix them in the future. And different subreddits foster different emotional tones. This study provides valuable insights for AI research, mental health support, and online community management. For the future research and academic contributions, there is still room for improvement. Future research would focus on enhancing the AI models to detect the sarcasm and expanding to non English subreddits for global emotions to analyze the global emotions and tracking long term trends to study how emotion change over time. This will further refine AI's ability to understand the human emotions online. So, thank you for your time, and I'd love to hear your thoughts. Do you have any questions?
So thank you, Dax. And
Thank you, sir.
I asked everybody any questions will be there. So speech. This is your emotional. Can you tell me the title once more?
Yes, sir. Just a second.
Emotions on Reddit, a deep
Yes.
dive to social media sentiment. So already one or two people have you presented on here. So your presentation is nice. And if anybody working on here on unveiling emotion on Reddit or emotions in social media sentiment to deep
Yes, sir.
dive into social media sentiment, these kind of focus can ask questions. Okay. So thank you, Dax. I have no
Thank you so much.
questions to you.
Okay. Thank you
So
so much.
now I ask Dax Kanodia. Dax, are you
Yes, sir.
there?
Yes, sir. Good afternoon, sir.
Yes, please proceed to your presentation.
Sir, is my screen visible?
Yes, your screen visible.
Good afternoon, sir. So my topic for today is road traffic prediction using machine learning. So every model has a problem statement. In my model, the problem statement from which I have developed a model are there is the increased travel time due to traffic congestion, fuel consumption and pollution, accidents and road safety issues, and also therefore there is a need for an accuracy traffic prediction system. The introduction. Rapid urbanization has led to severe traffic congestion, increasing travel time, fuel consumption, and environmental damage. Vehicular accidents result in huge human and economic losses worldwide. Traditional methods struggle to predict traffic accurately due to its dynamic nature. Machine learning offers scalable, precise, and real time traffic forecasting. The ITS, Intelligent Transportation System, integrates ML, sensors, and data processing to shift from reactive to proactive traffic management. the research objective from which the model is based, to explore machine learning algorithms for traffic predictions, evaluate and compare different models for accuracy and efficiency, propose a framework for real-time traffic management, investigate the impact of AI-powered traffic solutions on urban infrastructure. The literature review and existing studies. So there are various models in the market, like they have used CNNs, RNNs, decision tree, random forest, and the studies show how machine learning based traffic prediction improves accuracy. The explainable AI methods like SHAPE and LIME enhance model transparency. Previous research highlights the potential for integrating real-time sensor data. The key findings from the literature: hybrid deep learning models perform well, like CNN, attention networks. Studies emphasize the need for real-time data integration. Reinforcement learning used for adaptive traffic signal control. The combining of statistical and machine learning techniques shows promising results. So every model has some gaps and challenges. So here are the research gaps. The lack of real-time data integration in many models. Challenges with model interpretability and scalability. Need for privacy-preserving federated learning solutions. Further exploration required for optimizing traffic flow in heterogeneous cities. The dataset overview. So I have obtained the dataset from Kaggle, and the key features of the dataset are date, time, day of the week, number of cars, bike, buses, trucks, and based on the traffic situation, like flow of traffic is heavy, low, or medium. Now I have done the exploratory data analysis, like the first process is data cleaning, data pre-processing, and several things which are required for the model, like data cleaning, handling missing values and duplicates, the traffic trends across different weekdays or weekends, vehicle count distribution across congestion levels, and visualizations. Of course, it is necessary, like count plots, histograms, and heat maps. Feature engineering, handling categorical data, used label encoding, time-based features, extracted time of the day or peak hours. Feature selection, choose the most relevant features affecting traffic. So these are the machine learning models which I have used. There is decision tree, random forest, k nearest neighbors, XGBoost, and linear regression. So I have done the model training and testing. So it is splitted in two parts. The 80% is training part and the 20% is testing. And the hyperparameters tuning are used grid search CV. Performance matrix evolution. So these are the basic metrics evolution which are needed in a model, which are accuracy, precision, recall, F1 score, confusion matrix, and ROC curve for visualization. So these are the model comparison and results, which different model shows the accuracy. The best accuracy till now, it shows the random forest and XGBoost. The other models do not perform well in this type of data. The deployment strategy. Flask and Django API for real-time prediction, we can use that. IoT and Google Maps integration, and of course, cloud-based traffic monitoring. The challenges and limitations: data quality, missing values, inconsistencies, computational power like real-time analysis needs high processing, model interpretability. Some models act as black boxes. That means like there are no values or it must be empty. Scalability, issues for large-scale deployment. The future scope: IoT-based real-time traffic prediction, deep learning integration, explainable AI, federated learning for privacy-preserving predictions, autonomous vehicle traffic optimization. The conclusion: machine learning significantly improves traffic prediction accuracy. Random forest and XGBoost perform the best, which is 95% accuracy. Future enhancement like deep learning, real-time data, and cloud AI. Better traffic management leads to reduced congestion and improved traffic mobility. Thank you, sir. Am I audible, sir? Hello, am I audible, sir?
Yes, yes.
Yes, you're audible. Can you just present your screen once again?
Yes, ma'am.
Yeah. Can you just bring to this the novelty of your work?
Yes, ma'am. This is the methodology.
Yeah. So, have you compared your studies?
Yes, ma'am. I have compared my studies with several papers and findings, and
Mm-hmm.
then only I have come to a result of using the machine learning models.
Okay, okay. Can you just come down to this result part?
Yes, ma'am.
Okay.
These are the
So,
results.
can you go back to this previous slide one?
Yes, ma'am.
Yeah. Before that? Okay. Can you just tell me that why you have taken this 80% training data and 20% testing data? So
Because,
you can
ma'am.
do. Huh.
Yes, ma'am. You can continue.
Yes.
Because the training needs more time, and I have just spent 2 or 3 hours in training. And testing is easier, of course, because we have to just implement or give the path of the data set and it can predict the results.
Okay. So what will happen if I can take into this 90 and 10%? Like 90% training data and 10% testing data.
The change, there are no major changes, like it will act similarly only.
Okay. Okay.
So,
That's
am
all
I
from my
audible?
side. Yes,
Yes,
sir,
sir.
you're audible, sir.
Okay,
Yes.
okay. Sorry, I did not open the speaker on, so that's why.
No problem,
So,
sir.
can you go to the next slide?
Yes, sir.
Yes, yes, the table.
Yes, sir.
So this is linear regression accuracy. So you are getting random forest accuracy is more accurate than
Yes, sir.
XGBoost.
Random forest and XGBoost are the best performing models in my.
So any author has used these models?
Yes, sir. Previously, many authors have used this, and also like explainable AI like Shape and Lime. They have used like implementing in like IoT system in the CCTV cameras, but they have some research gaps or challenges. Then that's also I came to a result of
So,
using the machine
uh,
learning models.
so what you do, you make a column in which, sorry, you make a graph actually, bar
Yes, sir.
plot or like this. So where the authors have used these models
Okay,
and
sir.
and what is your findings, and make a graph that
Okay, sir.
your finding is better than that of the previous author. Okay,
Okay, sir.
for the random forest and the XGBoost
Okay,
actually.
sir. I understand it.
Okay. So thank you. That's Kanodia.
Thank you,
I
sir.
I asked Darsil Vaja.
Yes, sir, present.
I asked for your presentation. Please proceed your presentation.
Yeah. So is my screen visible?
Yes, your screen is visible. Move, yeah, make it full screen mode and please
Yeah.
proceed.
So greetings for the day, sir. I did a comprehensive review on computer vision and machine learning applications. These are a few points, constraints that will be covered in the presentation. So my review paper is based on AI transformations in modern industries, like how has AI has transformed with time along with technology. It includes deep learning applications, AI in agriculture, healthcare, and security, respectively. So before we get into the application business, let's first understand what computer vision and machine learning mean. What is connected with AI only? Computer vision is a field that mainly deals with visual data, whereas machine learning uses a set of algorithms which learns from data and improves performance over time. These algorithms can be implemented with computer vision to enhance efficiency and computational capability. Uh, Few importance of the implementation are automation and efficiency, that is, it reduces manual labor and processing speed. Accuracy and scalability also gets improved as ML-based CV models are outperform traditional systems, and also it is capable of processing vast amount of data quickly. Here are some real-world examples where ML-based CV models are implemented, including AI-powered diagnostic, crop monitoring, and facial recognition. The objective is to summarize recent advancement and analyze methodologies based on real-world applications and then identify challenges and future directions. So, early computer vision research focused on basic image processing techniques, that is edge detection and filtration, etc., as well as evolution from traditional machine learning methods to deep learning techniques has also been seen. But current trends includes the use of generative models for
Hello, hello,
Yes, sir,
hello.
you're audible, sir. Yes, sir.
audible? Okay,
So we
okay.
are starting with the next session,
Yes,
and
start the presentation.
yeah, we are actually, sir. Dehi Shaha has not been there, so we are starting with Dilip Kumar. So I think Dehi Shaha has just joined, so he'll be
Okay,
presenting next, right, sir?
okay.
So shall we ask Dilip
It's
to start the
is it
session?
going on the same? Okay,
So sequence
this
number
Dilip
17
Kumar,
for
I
Dilip.
think 17, number
Sequence is
17 serial
17.
number,
Yes, sir.
sequence number,
Sequence number 17 is Dilip,
sequence
sir.
number 17, right?
Yes, sir.
Okay,
And
okay,
16,
17.
Dehi Shaha is not presented, but he'll be doing. Yeah, after Dehi Shaha.
We'll be
So,
doing. Okay,
sorry, after Dilip Kumar, Dehi
okay.
Shaha will be present.
After Dilip Kumar. Okay, okay. Okay, please start. Please start your presentation.
Okay, sir. Good afternoon, everyone. My name is Dilip Kumar Anjana. I am excited to present my research on the behavior and demographic analysis of mutual fund investment decision in India. So these are the some factors on which I have analysis on the risk tolerance, fintech adoption, and regulatory reforms. So let's go to the what about we talk about the mutual funds. Okay, the evolution of mutual fund in India. The Indian mutual fund industry has grown significantly in the last 2 decades. In 2023, asset management reached 46 trillion due to the shift from traditional investment to mutual fund. This growth has been driven by rising income, financial education, and regulatory changes and technologies. However, mutual fund penetration in India is still lower than the global standards. Okay, so to provide this context, let's look at the key themes from the our existing research. First, we talk about the behavioral finance and demographic influences. So on when we're talking about the behavioral finance, the challenges that are come are like people are invest on the basis of their only overconfidence, loss awareness, and hard mentality. The hard mentality means they follow any other instruction. Due to this, there are many people making the losses due to their overconfidence and disorder. Demographic factors such as the age, income, education, and gender shape investment preferences. Younger investment, 25 to 35 years, prefer high risk equity fund, and while older investors, 50 plus years factor favors safe debt mutual fund option. Okay. In the fintech and regulatory reform, fintech enhance the accessibility to mutual fund through robo advice and mobile apps and digital platform. Mostly people nowadays they invest there through their mobile application. In the past, they go to the any many companies and they hire an agent and they through the. But now the time due to everything has changes. What my research is focus. We have analyzed the investment behavior and preferences in mutual fund, investigate the impact of behavioral biases on investment decision, and evaluate the influences of demographic factors on investment choices, and assess the role of fintech in mutual fund investment. These are the our five step methodology. First, we define the problem, collect the data, prepare the data, analyze the data, and interpret the results. While collecting the data, we have take the data from the Kaggle, where there are the 20 attributes such like fund size, fund 3-year return, 5-year return, 7-year returns, and what are the Sharpe ratio, beta ratio, and what are the who are the asset manager, who are the which company manage, and how old this fund is this. Before we go, while we pre-processing the data, there are any fund is mapping through their risk level, whether it is according the number, it is 5, 4, 3, or 2 or 1. We there are many missing values we have replaced with the average and
Hello,
visualization and
Dilip
data
Kumar.
validation. Yes,
Hello.
yes, sir. Yes,
Your
sir.
slide is actually fixed. It's not moving. Only the
Sir, I am
first page of
moving
your
right.
slide is.
I
Okay,
don't
I
know why.
think you have shared the application. Yes, now it's moving. Yes.
Okay, now moving.
Yes, now moving. But
Okay, sir.
previously it was
Okay,
not
sir.
moving. Yeah.
Okay,
Okay.
sir. Okay, sir. Okay. After the exploratory data analysis we have done on the basis of the data we have collected from the Kaggle, there are some result we can conclude from our analysis. The result which are saying that on the basis of the age, the younger people are investing more in the equity fund as compared to debt fund and hybrid fund, while as the more older people above 50 years where they invest more in the debt fund as compared to equity fund. Okay. Influence on behavioral biases dominate the most of the people. What are the factors that affect is mostly the loss aversion, herd mentality, and overconfidence. People they are the three most major factor. Okay. Okay. So while we are talking about the financial literacy and fintech adoption, the most of the 34% of the people are invest their investment of through their mobile apps, and 18% of their financial advisor, and 30% their bank portals, and 12% is through the AMC website. Right now, the mobile apps are the primary mode of investment as compared to in the past. They hire an agent and this. Okay, influence of behavioral while in the equity fund, the equity fund have the high beta, high Sharpe, and the Shortino ratio and high alpha, while in the debt fund they have lower volatility. Okay, so what we conclude from this findings we have come from the result after analysis is the Indian mutual fund industry is growing and driven by major various factors. Investor behavior is shaped by demographic, technology, and biases, and the mostly and important the literacy. Okay, the fintech plays a significant role, but financial literacy are regulatory and essential. Okay. Fintech has increased access, but trust remains effective nowadays. their growth of the fintechs is more increasing day by day, but many people are not feeling safe on this through. So many people are investing through the agent and the AMC website or their direct any bank portals. What are the future research direction we can do more work on this, are investigate the long-term impact of AI driven robo advisor on behavioral biases and market stability. Right now we have take the data from the Kaggle where there are mostly 20 attribute, and for the behavior we have taken data from the Yahoo, and this is the sort. But while we are conducting the cross country comparison to access culture, this can more wider and more detailed our explanation. And we can adopt the blockchain into this for enhancing the transparency in mutual fund transaction. Okay, thank you for sir for your thank you for the everyone attention, and if there is any question.
Thank you for your presentation. Can you please go to the result section, result
Yes,
slide?
yeah sir.
Um, can you please explain this particular graph?
Okay, sir.
Means,
This graph is saying about the people whose age between 18 to 25 is investing their money more in the equity fund as compared to debt and hybrid fund. While the people whose age is more than 60 plus, they are investing more in the debt fund as compared to equity and hybrid fund. This says that the people who are in the age between 18 to 25 are they taking more risk as compared to the people who are more than 60 plus ages.
okay, these data is based on the means only the statistical analysis means the descriptive statistics
Yes, we have taken
or
both, sir. We have taken, sir, both. We have taken the data from the Kaggle.
Kaggle. Okay,
Yeah,
no,
yeah,
you have taken the data from the Kaggle. That's okay.
uh,
Now, after taking the Kaggle data set,
yeah,
okay, after taking the Kaggle data set, now you have analyzed the data set and you found this result by using the only descriptive statistics that is only about the data, or you have used some kind of ML analysis there.
no, no, sir. I have from the data I have find out.
Okay, only from the data.
Yeah, sir.
So it means that no other type of any data analysis type means any ML learning you didn't apply anything.
No, sir. I right now I have not applied, but in the future I am trying to applying this ML and all this.
Okay, okay.
Hmm.
Then you need to means find some more insights from the data. Okay.
Yeah,
If you're not using some ML analysis, or if you're not using some kind of means means AI based some AI driven techniques or any learning, if you're not using it, okay,
yeah, sir.
then you must show something much better than this means statistical methods, but you can use some regression analysis also.
Yeah,
Okay,
sir.
so regression, statistical regression, linear or multilinear regression you can use.
Hmm.
Okay, scatter plots or some other statistical means predictive modeling you can show here.
Okay, sir.
Okay, otherwise the weightage of this particular study will be reduced in that case. Okay,
Okay,
so I suggest you to include some more statistical. If you're not going for the ML analysis, that is okay, but more
hmm.
statistical analysis you need to show here.
Okay, sir.
Okay,
Yeah, sir.
okay, okay. Thank you very much. Now you can stop presenting.
Okay, sir.
Okay, next one.
Sir,
Uh,
I'm left with my presentation, so can I give it right now? I was having some technical issues.
yeah, what's your name?
Dhwaniksha.
Yeah, yeah, yeah. It's
Yeah,
yours now.
yeah.
Yeah.
So is my screen visible?
No,
Sir?
it's till now it is not visible. Yes, now it is visible.
Yeah. Good afternoon, sir. So my topic is hybrid AI-based stock prediction and integrated framework So sir, this research explores the use of advanced AI techniques, including social network analysis, deep learning, and Hurst exponent analysis to improve stock market predictions by addressing the limitations of traditional methods. The proposed hybrid model combines multiple approaches to better capture market complexity and nonlinear dependencies. So this is the literature review, social network-based stock analysis. In this, there are three topics: interstock dependencies, social media analysis, and AI integration. So, sir, this shows how social network analysis helps identify influential stocks by analyzing interstock dependencies and investor sentiment from platforms like Twitter and Reddit. AI techniques such as NLP and sentiment analysis are used to extract market trends from unstructured social media data, improving stock market predictions. This is also the literature review, AI-driven stock selection, traditional versus AI approaches, machine learning, and reinforcement learning. This shows how AI-driven stock selection methods such as k-means clustering, LSTMs, and random forest outperform traditional models by categorizing stocks more effectively, like, for example, growth, stable, underperforming. Machine learning techniques like SVM and deep neural networks analyze diverse data to predict stock performance, while reinforcement learning adopts portfolios dynamically. 2.5 indicates a trending market momentum strategy, whereas H less than 0.5 suggests mean reverses, and H equal to 0.5 aligns with the efficient market hypothesis. Metrics varied dynamic models MVDM. This model metrics varied dynamic models which excel at capturing nonlinear dependencies in stock prices, offering better forecasting accuracy than traditional linear models when integrating with deep learning. Example RNN, LSTMs, MVDM enhances time series predictions by modeling both short-term fluctuations and long-term trends. A key strength is its use of dynamic Bayesian inference and expectation maximization, which refine parameters for robust performance. This is the methodology, sir. This methodology for data collection and pre-processing using historical stock data from the past 10 years uses GA to identify impactful variables and normalization to standardize the data. There are three different types of methodology: correlation-based MST, centrality measures, and market structure changes. So this is the flow chart for this. Network-based analysis of stock independence using a correlation-based minimum spanning tree to map relationships and centrality measures, degree eigenvector betweenness to pinpoint influential stocks. It also examines how market structure shift during crises like the 2008 crash and COVID-19 pandemic. This is the results and discussions. This section presents the results of the hybrid AI model, showing it outperforms traditional methods. Example ARIMA, random forest, LSTM in stock prediction accuracy by better capturing market trends and reducing errors. The comparative analysis confirms its superiority using metrics like precision, recall, and F1 score. Conclusion. Uh, this research concludes that the hybrid AI model combining social network analysis, clustering, deep learning, and green database optimization significantly improves stock prediction accuracy and efficiently for investors and algorithmic trading. Future directions include integrating real-time data, reinforcement learning, quantum computing, and blockchain to further enhance performance alongside explainable AI to increase transparency and trust. Thank you, sir.
Thank you very much for your presentation. Okay, can you please do not stop sharing,
Yeah.
please? My question is, how can you find the dataset and what is the resource you found the dataset to analyze this?
Sir, can you repeat it?
The source of your data means where do you find the data?
Sir, from Kaggle, I have found the data.
Okay, and how many samples have you
I have taken 5 samples.
Uh, 5 samples.
Yes.
Samples means the
No,
number of
sir, I'm
rows.
talking about 5 research papers. Like I have
Okay.
taken data from that.
Okay, 5 research papers.
Yeah.
Okay, and the samples means the number of rows. How many rows are there? Means you analyze the data in means you have shown
The
that
15 approx 1500.
approx 1500. Yeah, yeah.
Yeah.
That's what is the LSTM, right?
Yeah. Yeah.
Okay. And did you compare your means have you
No,
compared
sir,
your
I'm
result?
comparing it
Or-
right now. I have not compared it, but I'm working on it.
Okay, understand,
Yeah.
understand. Okay, okay, understand.
Okay. Thank you,
Okay,
sir.
try to when preparing the paper.
Yeah.
Okay, means you must include the comparison also.
Okay, sir.
You
I'll
must be
include that in my
yes,
PPT.
and also not in PPT in
Uh,
paper. Okay,
okay, sir. I'll
comparison.
include that in the research
Hmm.
paper.
Yes, research paper and also include the figures of your
Okay.
comparison data and your the graphs of the comparison also. Okay,
Okay,
means
sir. I'll include that.
the results graph,
Yeah.
everything. You
Okay.
must include that one. Okay.
Okay, sir.
Okay. Thank you very much. You
Thank you, sir.
can stop the
Yeah.
presentation.
Yeah.
Okay. Now our next presenter. Then will be hello. Is who is the next?
Yes, sir, I'm the next.
What's your name,
Am
please?
I audible, sir? Am I audible, sir?
Yes, yes, you're audible. You're audible.
I am
Your
the
name, please.
myself, Dhiyesh Shah. May I start presenting, sir?
Yes, yes, yes. You can start presentation.
Sure. Is my screen visible, sir?
Yes, your screen is visible.
So, good afternoon, everyone. Myself, Dhiyesh Shah, and my topic is sentiment analysis on IMDb movie reviews. So, talking about the topic, sentiment analysis is basically NLP technique of analyzing online prices of writing to determine the emotional tone they carry. It is an attitude, thought, or adjustment or judgment prompted by feeling. So sentiment analysis has many applications like movie review, stock market prediction, social media monitoring, etc. And one of them is IMDb movie reviews. That is our topic today. So talking about the introduction, sentiment analysis, as I told you, is an NLP technique that identifies whether text expresses a positive, negative, or neutral sentiment. It helps businesses researchers to understand public opinion, and in the film industry, analyzing IMDb reviews helps filmmakers and improve marketing and future productions. So briefing about the problem statement, the vast number of movie reviews on IMDb makes it challenging for users and filmmakers to analyze audience sentiment efficiently. So manual classifying these reviews is time consuming. So for that reason, a robust sentiment analysis model is needed to automate this process, providing accurate and scalable insights into public opinion, aiding decision making for both viewers and the film industry. So our primary objective is to develop a sentiment analysis model that can classify IMDb movie reviews as positive or negative by leveraging machine learning techniques as aim to automate sentiment detection efficiently and to use analyze accuracy of different machine learning models. We will compare various machine learning models to determine their efficientness in sentiment classification, evaluating the accuracy, precision, and recall of each model. So this is the literature review. Literature review is basically the studies that have been made till now by other researchers. So several studies have explored sentiment analysis using various machine learning and deep learning techniques, while other studies have traditional approaches like naive Bayes and support vector machines. have been widely used for text classification, while deep learning models such as LSTM and transformers have shown improved accuracy by capturing contextual meanings. Researchers have also experimented with feature extraction methods like TF-IDF and word embedding, enhancing sentiment detection. So there are some key findings and gaps in our research. So, however, key gaps remain such as handling sarcasm, ambiguous reviews, and domain-specific sentiment variations. Our study aims to address these gaps by evaluating multiple models on IMDb reviews to determine the most efficient approach. So this is the dataset overview. We have taken our dataset from Kaggle, and the dataset has 5 positive or negative. So this is the methodology, proposed methodology of our research. So it goes like first we collect our data set, and then we pre-process our data. We apply feature extraction methods. Then we implement some models, and then at the end we compare our model based on the matrices. So this is the flowchart of our methodology that I explained just now. This is the data pre-processing technique. That is the second step of our uh, process. So it consists of several steps like tokenization, stop word removal, lemmatization, and removing special character and punctuation. Tokenization is basically breaking the text into individual words. Stop word removal removes commonly used words that do not carry any sentiment or meaningful or any meaning. And stemming and lemmatization converts word to the root forms to standard the vocabulary. Removing special characters and punctuation is to ensure that only meaningful words are retained. We used feature extraction technique method called TF-IDF, which stands for term frequency, inverse document frequency. It assigns the weights to words based on their importance. This is the model classification. We implemented 3 machine learning models named logistic regression, naive-bayes, and support vector machine. Talking about logistic regression, it is this model predicts whether a review is positive or negative by calculating probabilities using a mathematical function. Talking about naive-bayes, this is a probability-based model that predicts sentiment by assuming each word in a review contributes independently to the overall sentiment. And SVM is a support vector machine that finds the best decision boundary that separates positive and negative reviews. So these are our models that we implemented. Uh, and these are the matrices that based on which we compared our 3 models. Talking about accuracy, accuracy measures the overall correctness of the model. Secondly, our second matrix is precision. It is the proportion of correctly predicted positive reviews out of all predicted positives. And recall measures how well the model identifies actual positives. So this is the result of our research in a tabular form. We get to know about from this that the logistic regression is identified as the best option for sentiment analysis with best accuracy of 0.8745. That is 87.45%. It also preserves a balance and balance of precision and recall. Moreover, logistic regression is computationally less expensive and achieves comparable accuracy than SVM, which is more capable and efficient for large-scale sentiment classification approaches. So this is a model comparison based on performance metrics, which is basically the representation of this table in the form of a bar graph. So we can see in this figure that we can see in this the comparison that logistic regression and SVM gives nearly same recall and accuracy, while database gives high precision but very less recall. So, talking about the conclusion, so in conclusion, our study applied sentiment analysis on movie reviews using TF-IDF and three machine learning models that are logistic regression, naive and a support vector machine. So we see that the logistic regression emerged as the best model with 87.45% accuracy, offering a balanced trade-off between precision and recall. Naive had a high precision but very low recall, while support vector machine achieved the highest recall but slightly lower precision. So these are a future scope. It can be used in hybrid models by combining deep learning with traditional machine learning for better accuracy. It can also be used for aspect-based sentiment analysis by identifying sentiments on specific movie aspects, and also in real-time analysis by implementing sentiment analysis or for live review streaming, and also in improving movie recommendation based on sentiment trends. So this was all about a presentation on the topic sentiment analysis of IMDb movie reviews. So anyone would like to ask any question?
Okay, thank you very much for your presentation. Okay, means you have collected the data from Kaggle only?
Yes, sir. I collected the data from Kaggle.
Okay, okay. Can you go to the result section, please?
Sure.
Okay, so you used three algorithms: logistic regression, Navy base, and SVM. Okay, can you tell me actually means what is your prediction? Means which one is prediction variable? The name of your prediction variable.
Sir, we see that logistic regression is the best model that we used.
No, no, no. That is okay. That is visible from the table only. I'm talking about your data set. Means actually what you are going to means your target variable. What is the name of your target variable?
Sir, I'm not getting that.
You analyze the data set?
Yes, sir.
Okay. There are many features are there in the data set.
So the data set is basically of 5,000 movie reviews.
Yes, the 5,000 movie reviews, it means your sample size you are saying about. But what are
Yes, sir.
the column names? I'm talking about the column names. What are the names of the columns? Do you remember?
The first column is about the reviews, and the second
Reviews.
column is about the positive and the negative reviews. I mean, it states that the review is positive or negative.
Okay, then my question is what actually you are going to predict from your model? Okay, every model, if you're using logistic regression or Navy base or SVM, whatever, there must be some dependent variables, must be some independent variables. So what's your
Yes, sir.
dependent variables here? Actually, what you are going to predict in this model?
So our prediction is all about the model that is best for this research.
No, 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 no. That is not prediction. That is the modeling. Every model is going to predict something. And so you are suppose going to predict the review, whether the positive review, if you input some data set, then what should be the outcome? Whether the outcome is positive or outcome is negative, how accurate is there? My question is, what is you are going to predict something here? You're not getting my
I'm
question,
not.
right?
Yes, sir.
Okay, forget about it. Okay, okay. Comparison table you have shown here. So here it is. Okay, it's okay. Now you can stop presentation.
All right, sir. Thank you, sir.
Okay. Okay, next presenter, please.
Good afternoon, sir. Am I audible?
Yes, you're audible. Your name, please.
My name is Gaur Saxena.
Go, God, section. Just wait.
Okay, sir.
Yes, you can start presentation now.
Okay, sir. Let me share my screen.
Screen is not visible yet.
It is now visible. Hello.
No, it's not visible yet.
Let me reshare it just a second.
Yes, yes.
It is now visible, sir.
No, it's not visible yet.